Recording is in progress. Good evening. This is Co-Platoon, Echo Platoon, evenings, weekends. It is July 18th. I'm your host, Jordan. Today, we're getting into HTTP servers. Basically, at a most base level, what an HTTP server kind of does, what you expect from it, and how to interact with it. This is about as small of a bite as we can hand you, I guess, for getting into this kind of thing. I guess we'll just get into it. Servers, request, responses. We will be interacting with the server, looking at the request we're sending, talking about the request we're sending, and looking at the responses and seeing what you can get from response. Before we get any further, does anyone know the different types of HTTP requests?
Is that like get and post?
There is get, there is post. Can you think of any more?
There's delete, right?
There is a delete. I got one more I want to hear.
Update or patch.
I didn't hear the one I wanted to hear. Both of those are similar to this one. Update and patch are types of unless somebody said it. Yeah, there you go.
What is it?
Unless,
All right.
You may in the future be interacting with patches and updates. I'll bet you won't. I'll bet you be using put requests instead. They're significantly more common. They do a lot more work. The other ones exist, and I think generally update and patch are more efficient, but 9 times out of 10 that doesn't matter. We in this course will be usually generally we're doing a get, pull information in. We're doing a post, which is here's some brand new information, do something with it. Puts is here is some information that you already have. Update, what you've got, change some stuff you've got, get rid of some stuff, whatever. Basically, here's a new version of what you already have. Use the new version. And then delete, which, as you can imagine, deletes the thing. I know I'm being very vague, but there's a lot of different things you can do with this, and generally good HTTP verbs are those four, and good API knows what to do with those kind of verbs. So you've certainly heard about servers before, but what is a server? To answer this question, let's go over to ChatGPT. We can power read through all of these things, I guess. Basically, I don't like reading to y'all, but I think I'm supposed to. In the context of web application, a server is a computer program or machine that handles requests from client devices such as web browsers and sends responses back to those devices over a network such as the internet. When a user types a web address or URL into the browser sends an HTTP request to the server asking for the web page associated with that address. The server receives a request, processes it, generating a response that typically contains the requested web page content along with any necessary additional data, images, style sheets, or scripts. So up to there, a server is going to receive a request in the form of a URL. That's how you interact with servers, generally through a URL. They're serving, what's the best way to say that? They're serving a URL. You hit a URL or URL that's going to take you to that server if you're connected to it properly. Based off of the URI, it's going to do additional things, or depending on what you send that, going to a website like www.example.org. I think we're doing, is that org? Yeah, that's a GET request. If I fire off a GET request with curl, it's giving me all this junk, and we'll see that here in a bit. That's the only kind of request I can do while typing it in up here. Everything else, we're still interacting. We're still giving it a URL to go hit. We're just not sending a GET. We're sending a post, patch, put, delete, update. There's others. It knows what to do because it's looking at your request. It's looking at the type. It's looking at the URL or the URI, the end of it, and it basically is running real simple logic on the back end saying, oh, it gave me, it wants to, if someone hits me here, and they want me to, and it's a get request, well, I'm going to give them this. Or if somebody hits, this URL and it's a post, well, I'm going to have to take a look at their request and see what it is they're trying to post. That's more or less the dance there. A server has paths set up that you can type in or go to or fire off requests to, and it's got logic that tells it what to give you back or what to do on its side and then how to respond. A good server tells you it got your request, responds or does something, and then tells you that something happened. You don't really, it's not a good move to, send some data to a server and it just sit there. It should say, hey, I got it. Hey, I'm working on it. Hey, I'm done with it, right? Otherwise, you don't know that it worked. And then we have to really dig into these curl requests, these responses to actually figure out if something worked or not. And you don't really want to do that. Once the response is generated, the server sends it back to the browser as an HTTP response. That's what I was just talking about, which the browser then displays to the user. This entire process from the initial request to the final response is known as the request response cycle. Jordan says dance. It's important to note that the server may perform additional actions during the request response cycle, such as retrieving data from a database, running calculations, or interacting with other systems. However, the core functionality of the servers will receive requests, process them, send back responses, forming the backbone of the client server module. So, like I mentioned, the server is going to be doing things on the back end when it receives your request. Sometimes that just means immediately responding, but other times that could be, hey, I need to go hit the database, take stuff out of the database, let you know things happened, or I need to go fetch information. I need to change something over here. I need to trigger that. I need to make the page change in some ways. Those are all kind of things that a server can do. And before we started recording, I said I didn't really like this assignment afterwards, but I kind of do a little bit. It might frustrate you all a bit because you have to really learn you have to flesh your debugging skills to even get started. That's actually a pretty good response. Please don't replace me, ChatGPT. To make it even simpler, a server is something that responds to requests. Yep. What about requests and responses? Requests and responses are governed by a set of protocols. In other words, they have to conform to agreed upon conventions. Both requests and responses need to contain certain information in a certain order. That is correct. Your requests and your responses are always going to contain a few, things. A request will have a request line, headers, and a body, which is optional, but the body is where you would have your information. If you're trying to send something to a server, that's going to go in the body, right? If I am posting to a website that is like the Pokemon website, and I want to, send my favorite Pokemon, I need to have that Pokemon name in the body and have that sent out. That's usually JSON. You can send a file. You can send a lot of different things, but very often JSON is the way we handle that. But I went straight to the end. The request line. This is going to include the HTTP methods, get, post, delete, that the client wants to use, as well as the target resources. Resource, which would be the URL or the file path, wherever it is that you're getting your stuff from, or you're trying to hit on their end. Headers have a lot of stuff, but generally I like to consider it metadata. These provide additional information about the request, such as the client's user, agent, content type of the request body, and any authentication credentials. That's the big one. You'll be seeing a lot more of authentication when headers when we start getting into authentication. That's where we'll be plugging in some of our tokens, cookies, things like that. Those go in the headers. When you send a request, it comes with the headers, and then you'll be identifying separate things in there, and that's all good for the server. The server needs that very often to be able to do things. If it is authentication, let's say the server, I went to example, .org, but what if it was a, kind of a locked one, and it's something that is locked behind like a paywall or sign, you got to sign up or something. If this GET request was just an anonymous GET request, it wouldn't go through. I would need to, in the headers, say, hey, here's an auth token, like in a JSON object, you'd have a key object pair. my token is A, B, C, D, F, G, whatever. And that would be required by the server to even let you in. So we'll be seeing more of that. We'll be seeing a lot more of that. HTTP response status line. This includes an HTTP status code indicating whether the request was successful or not, as well as a status message providing more details. This is one of those important things you want to see in a response. Have you ever seen HTTP cats? This. It's got every HTTP code known to man in cats. You don't need to know all these, and you don't need to use all these. 9 times out of 10, you're going to see 200, 201, 202, and then like, what is it? You do get 301 a lot, but more so that's something's not routing properly. And 403 is probably, there's a few you're gonna see, but 403, 405, these are ones that are real common with setting up application. You're going to be sending a post request to an endpoint that doesn't allow post requests. You're going to get a 405 back. If I tried to send a picture of my mustache to example.org, I'd probably get a 405. It would say you can't do that. I could prove that to you with a curl request. We're not going to do it, but that would have been a good example. And then 500s, 503s especially. 503 is general server unavailable errors. One of my favorite interview questions is you get a 503 on one of your applications. What is it? And there is no right answer. You just let them sweat and talk about it for 10 minutes, and you keep telling them good idea, but no, that's not it. It really shows your ability to kind of work through problems and think about servers. It's real mean to ask that to Code Platoon graduates because we don't really dig into it that deep, but it is interesting to see what you guys say sometimes. Responses have headers as well. Responses have bodies as well. You'll see that all this is going to be wrapped up into the body of the response. The header is going to contain some good stuff too much to talk about, but we'll see it here in a bit. Friendly reminder, we saw this yesterday, but we're going to be using it today for the challenge. So I hit this. This is basically doing curl example.org, but we're going to do it here. I don't like that one. Cool. I fired off a curl request. What did I get back? By the way, -v verbose. If you want to know all the things you can do with curl, you can always do the word man for manual before anything built into bash. And there should be a nice manual page with all these different things. Does anyone know what curl means? Why is this? Where's the C come from? What is curl? What if I want to be a jerk and say, oh, it's not called curl?
Does it stand for client?
It does. Yeah, client for URL. Somebody corrected me one time and I was like, man, you don't have enough stuff to worry about in your life. Everyone's going to call it curl. Everyone knows what curl is. But if we were to go down, you can navigate this as you would a less document. Oh, there's so much here. We're not going to find V very quickly. But -v is verbose. What the hell? Oh, there it is. There's a quicker one. Just kind of some of the basic stuff with curl if you don't want everything. Very, very often, especially in bash, -- help will give you some kind of quick stuff. Verbose. Make the operation more talkative. Cool. Now I've wasted enough of y'all's time with that. Here's what we got. This is very useful. These are things you're gonna get with verbose that you wouldn't get normally, which is, hey, I tried to make the connection. I made the connection. Boom. Here is our response. The main bit of the response. What do we specifically call that here? This is going to be the status line. Sorry, I'm messy. So it was a get HTTP request. 1.1, I think is the version type. I forget. This is where we went. This is the user agent. This is what it accepts. It accepts everything basically going exactly here. These are some of the headers. We got some more of this information kind of being replicated. The HTTP request, we got a 200, which means okay. Age, I think that is the like as long how long that page has been up without change. I could be wrong. Again, a lot of the stuff we don't interact with on a very very often. Cache control, content type. This is cool. This is a text/HTML char set UTF-8. You may have seen that when you're setting up HTML pages, right? This is the date we did it. Get some tags. This is when this expires, and we'll need to get another GET request. Some stuff. This is where the server lives. Yeah, content link. So here's the body of the request itself. This looks a lot like pure HTML. That's because it is. Jordan, that doesn't look anything like what you got over here. Yes, it does. Look, there it is right there. All within this div. And then everything else is CSS, metadata, stuff like that. The header, or sorry, the heading tag. But there it is. And then connection to, yeah, basically you're done. I disconnected. Real cool, right? Does that all make sense? Y'all understand that all this right here is basically what happens when you just go somewhere with a GET request? You may think you'll never want to see this kind of data here, but you will. It is going to be useful someday, especially when things just aren't working the way you expect them to. Okay. Oh, I didn't have to ad lib all that. Protocol request, or sorry, protocol for the request. It's this stuff. Remember that this protocol is just convention, is just byte strings that conform to certain expectations. The first line is probably the most important one. Basically, yeah, it said we use curl to make a get to here. It would say /users if we want to go to /users. We can prove that. I don't think we're getting any difference there, sorry. But we will see it here in the curl request. So did something work? Did something not work? I don't know. It looks like it worked, but let's see if it actually accepts that. Because, I mean, here's a good example. I went to example.org and I put in /users. Does it actually serve /users, or did it cache the last thing we had and now it just kind of accepts everything? Or maybe there's something bugged here. Don't have a great idea looking right there. However, we can see, yeah, it does. It knows that you sent this, and that's cool. It's fine with that. I lost my spot, sorry. The server receives requests, do whatever processing is needed, blah, blah, blah. The first part of the response also needs to conform to the HTTP protocol. I think you do need all of these things. Nope, never mind. Most of this is optional, will vary depending on the server. So it can give certain things back. There are some things it does, it is expected to do to work on the internet, but a lot of times this, what I'd call metadata, is kind of extra stuff. And if you're thinking, well, that's a bunch of junk, I don't want to put that in my server. If you're using something like Flask or Django, a lot of this is going to be baked in for you. You're not going to be hand rolling all these responses. If I just want to make a cool website about cats, I probably don't want to have to go configure all these response things here. My tools will do that for me. Only after this bullet point do we get the actual payload. Remember, at the bottom, that's where we actually saw the HTML document. This hands it back in HTML. It doesn't always. Sometimes responses are in JSON, which is a lot more useful. I think we can just go straight here. Not curl. Look at that. JSON. That's not very pretty to look at. That wouldn't make a very good website, but that's a heck of a lot easier to work with, right? Because if I were to just return HTML, like this, right? And I wanted to sift through that. How the heck am I going to do that? If I'm hitting an API with Python and that's the body it sends back, I'm going to be mad because now I have to turn that into a string, break it down, parse it out, figure out what the body is, and do a bunch of work with it. If its response comes back in JSON form, that's significantly easier. I can just say response.userid and get the user ID, right? So sometimes pages return something nice to look at, something you can visit in the UI, and sometimes they just return JSON. And it doesn't look very good to look at here, but again, a lot easier for us to work with. I don't have to do anything to this data. I can just say, hey, Python, convert this to a dictionary and then work with it. Does that make sense? I feel like I glossed over that real quick. Any questions about anything I've said up to this point? When we're talking about a lot of this base level internet stuff, sometimes I run fast through things that I shouldn't.
Well, what would it look like if you did a request for a JSON on the example domain?
Well, I can't.
Oh, you can't
It
do that?
doesn't-
Okay.
It doesn't give me JSON. This here gives JSON. That's just the way that this URL is set up. The previous one is set up to send basically an HTML page. It directs you to an HTML page, and that's what you get back. If we were to go to facebook.com and get requests that, you get some weird stuff. You can't really, get JSON back. But if it's an API that just has endpoints to hit, that's more for developers. That's not really for looking at, right? And it doesn't always have a nice response that breaks out nicely in a page, and there's no need for that. Some endpoints are for interacting with code, and some are just for looking at. Any other questions?